that's the strength transformation equation presented earlier. Now, also strength transformation that apply with the Mohr circle also have analogous to stress. So let's talk about that here. Mohr circle for strength. So it analogous to stress that we learned in the previous class, and it allow determination of shear and normal strength on any plane. Allow determination of shear and normal strength at any plane. Any plane. So give you an example here. If we have a strength block, so we have instead of sigma we have epsilon. Let's assume epsilon x 50 micro inch over inch for example, and epsilon y in this case in the body in compression going down into the block, so 100 micro inch over inch or millimeter over millimeter, so that the other way, and then go down here. So the that is the normal strain, and now the shear strength. Let's assume that gamma xy, and we have that is gamma yx, so that gamma equal to 150 micro inch over inch. And the question is how we can draw the Mohr circles. To determine the Mohr circle, we need to find out the center, location of the center, and then the radius. So if you apply and recall what is the here we have in this case epsilon x equal to 50 micro and inch over inch. So and then we had epsilon y negative 100 micro and gamma over 2 gamma xy equal to, by the sign convention for Mohr circle, if you recall. So in this case, the gamma, if you apply equation, then it for the positive y x plane, the vertical plane on the right, it going down. So it negative if we use the equation to that one, as you can see, never 70 150 micro inch over inch. Okay, and then we have gamma over 2, because that's the analogy we do later on. So you have gamma xy over 2 equal to divide by 2, so negative 75 micro. If we use the Mohr circle, we have a note here, it equal to 75 micro in Mohr circle. Why is that? The sign convention for the shear stress and shear strain for Mohr circle is defined by the clockwise rotation. It will, if that stress or strain tend to rotate the block, the blue block here, clockwise, then it's positive. Counterclockwise, negative. As you can see, for the shear strains on the vertical plane on the right, it tends to rotate clockwise. So that's why positive in the Mohr circle and negative in the analytical method when you do the calculation. So from that, we can go ahead to find out the sigma average and sigma and the gamma max over 2. Sigma average equal to epsilon x plus epsilon y over 2, 50 plus negative 100. We will get that one is negative 25 micro, and we have gamma max over 2. That is actually the radius of the Mohr circle. And if you recall that gamma max over 2 equal to that equation here, so we just apply that in here. It will be square root of epsilon x minus epsilon y over 2 square plus gamma xy over 2 square. So from that we can have here 50 minus 100 divided by 2 square plus 150 over 2 square, and that equal to about 106 micro, and that actually the radius. So as you can see the radius now. So from that, what do we have? The center and the radius, right? So AB for the Mohr circle. We have AB, the center, equal to epsilon average 0. In this case, we have negative 25 micros 0. And then we have the radius equal to everything tau max. Now tau become gamma over 2. So gamma max over 2. And from that equation, we have 106 micro.